Today is our third lesson on data handling, and that is on line graphs. We're learning how to use graphs. Today's success criteria is to be able to collect data and put it into a bar graph or a line graph, to be able to read and interpret scale in a graph, to understand why there are different types of bar graphs, explain the difference between a bar graph and a line graph, and to put the correct titles on a bar graph and a line graph. So let's just reflect on our prior learning. I want you to pause this video after I've read these questions and have a think. What is the point of data handling? Why do we have it? What titles do we need to have on a bar graph? And what is a scaled graph and why do we use it? You might want to answer all three of these questions or maybe just choose one. So the point of data handling is that we need to identify a problem. Last week I spoke about how one of the problems that was identified in the eco group was that there was a lot of traffic outside the school. You then need to collect your data. So we collected data on the methods in which people went to school. We then processed and represented that data by putting it into a chart and then a graph. That allowed us to interpret and discuss the data, and what we found was that the biggest problem was a lot of people didn't want to walk or cycle to school when it was raining. So we had to come up with solutions for what to do when it was raining to reduce the amount of traffic. So that is the data handling cycle. Whenever data is collected, it is because they're trying to solve a problem. The titles we need on a bar graph, well, firstly we need the chart title. What is the graph about? We also need the axes titles. So on we have the amount of pupils, for example, on this one to show what the scale represents, and we have the method of travel to show what each bar represents, and with that the categories. If you don't have these titles, it doesn't make the bar graph clear, we don't know what it's about, and it's harder to read. So they're super important. And a scaled graph is when we have, for example, in this pictograph, one circle equals more than one. So we had to make sure there's a key to show what the scale is. So in this case, one circle equals 2 children. So half a circle will equal 1 because half of 2 is 1. So you need to be really careful when you're reading graphs when they're on a scale. For example, you may look at red and think, oh, that's 4 children. But if each circle is worth 2, then it's 2 times that, so it's 8. Now, the reason we have scaled graphs is because if there's too many people or too much data, then the graph would be huge. So we have to scale it down so that it's visible to see. Here's an example of a bar graph that's scaled. As you can see on the left, it's going up in 5s. So again, you need to be careful. If we look at salt and vinegar, some people might say, oh, it's 20. But it's in between 20 and 25. And a bit closer to 25, so it's likely to be 24. So we also have there are different types of bar graphs. Here is an example of a bar graph that is used for measurement. So these are called a histogram. Now they're set out the same as a bar graph, but they don't have spaces in between each bar. So you can see that this is to represent the number of plants and the height that they've grown. So to read this graph, to practice reading this graph, I've got a few questions. So how many plants reached above 20 centimetres? So if we look at the bottom, the title says height in centimetres, and one of them says 20 to 29.9 centimetres. So that shows that that's what that bar represents. And if we go to the scale, we can see it's going up in 2s. So that bar is sitting in between 8 and 10. So the number 8 between 8 and 10 is 9. Only one plant reached a certain height. Which height was that? So you want to go to your scale and see which bar is sitting in between 0 and 2 because that will represent 1. And we can see that only one plant reached 40 to 49.9 centimetres. And how many plants were there altogether? Well, we would need to count each one that the bar is set at. So the first one is at 4, then we have 6, then we have 9, then we have 3, and then we have 1. If we add those all together, we get 23. So there must have been 23 plants altogether. So you probably won't use these often, but they are pretty much the same as a normal bar graph, except it's to show measurement and there are no spaces between them. This bar chart shows how many people visited a skiing chalet throughout the year. How many people visited together in the 2 busiest months? So this is quite a tricky calculation. You need to first of all look at what the 2 busiest months were, and they'll be the tallest one. So that's October and November. Now they're both sitting at 20. So if there was 20 visitors in October and 20 visitors in November, then the answer must be 40. Now, the whole point of graphs is to interpret them. So this ski chalet business would have to think, why are those months most popular? Now it may be because there are... Have a little think about that first of all, actually, before I give you the answer. Why do you think October and November were the most popular months? Pause this video now. Well, it's likely to be because there are school holidays in October. Possibly because that's when the best snow is as well. That's when they have the best snowfall. So it's the best time to ski. Another type of bar graph is time graphs. Now time graphs are the same as bar graphs, except they're almost like flipped on the side. So you can see that the scale is now at the bottom and the categories are now at the side. And we use time graphs to show data over a period of time. So here we can see they've got the number of days and the days of the week. So what scale is this graph going up in? 0, 10, 20, 30, 40. It's going up in tens. Why do you think this graph is tilted? It's to represent time. Time is more linear, so it goes across the way. What is the problem with this graph? Have a look at everything. Does it have all the titles? What's the difficulty with this? There's no title, so we don't actually know what the graph is about. It's got number of days and days of the week, but who knows? So that's why it's really important to have a graph title. So to summarise, bar graphs are made to show data that we can then analyse. There are scaled and non-scaled bar graphs, and that depends on the amount of data. If there's not that much data, we don't need to scale it. We can just go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If there's a lot of data, we might need to go up in 2s or 5s or 10s so that the graph isn't huge. Like this example we went over. There was quite a lot of people that we had in the survey, therefore we had to put it up in 2s, otherwise the graph would be massive. Some bar graphs are to represent measurement, like this histogram that we went over. It was a measurement of the height of plants. And some are for time, and they're flipped on their side. So these are all bar graphs. They're just represented in a different way, and that's simply so that you can read them as easy as possible. So let's move on to line graphs. Now, line graphs are used to show data over a period of time. So it's over a short and long periods of time. When smaller changes exist, line graphs are better to use than bar graphs because some bar graphs may look like they are at pretty much the same height when there's quite a tiny bit difference, and line graphs show that a bit clearer. Line graphs can also be showed to compare changes over a period of time for more than one group. So if we look at this graph, it's got the shadow in a patch of garden. Now the scale is going up in tens, and that's length in centimetres, and we can see the time is in hours, from 9 o'clock in the morning to 3 o'clock in the afternoon. And the line basically shows how big the shadow was at each time. So let's see what titles line graphs need to have. Now it's pretty similar to bar graphs. You still need a chart title, so we know what the chart's about. You still need, at the bottom, you need to put measurement. So what's the measurement of time? It's the time measurement. So what type of time is it? Is it days of the week? Is it weeks? Is it months? Or in this case, it's hours, okay? We need to show what is being measured over time. So in this case, the length of a shadow is being measured over time. And there needs to be a clear scale. This one is going up in tens. So let's see if we can analyse this data. What scale does the graph show? It's going up in tens. What time was the shadow the longest shadow? Well, if we look at the graph, the longest it got was just above 50 centimetres, so about 54 centimetres. And that was at 3 p.m. Why do you think the shadow keeps changing? Because of the movement of the sun. So here's another one. Now you can see the crosses are plotting the data. So this one is measuring the height of a plant over a period of time to see how much it grows. So you can see that it was 0 centimetres on the first 3 days, and then it started growing. So what height did the plant reach on Wednesday the 17th? Well, we need to find Wednesday the 17th at the bottom, and then look up and see where that X is crossed. It's in line with 8 centimetres. So the plant reached 8 centimetres on Wednesday the 17th. This is a graph showing kilometres travelled over a period of time whilst riding on a bike. What is the difference between the distance most travelled and the distance least travelled? Well, we can see that it's just the period of time is just in weeks, from week 1 to week 12, and the scale is in kilometres, going up in 2s. So the difference between the distance most travelled, well, let's find out. What's the highest, where's the peak in the line? It goes up to 8 on week 7. So that's the highest it got. The lowest it got, the least travelled, was 0 on week 12. So the difference then is going to be 8 kilometres. Because on week 7 they travelled 8 kilometres, and week 12 no kilometres. So the difference in distance is going to be 8 kilometres. So let's learn how to draw a line graph. Well, your first step is to draw the axes. We call this one the y-axis and this one the x-axis. You must use a ruler if you're doing it on paper, because it can be very messy if you try to draw the line without a ruler. Then, step 2, you draw your scale and your titles. So first of all, you need to think, what's your scale going to be? Is it going to go up in ones because you've not got too much data? Or is it going to be scaled? Okay, now you have to think about what is the highest amount in your data. So for example, I have measured the amount of rainfall across a week and the highest amount of rainfall I didn't think would be more than 9 mm, so I've just put it up to 9 mm. But if there was more than 9 mm of rainfall, then I would have put it higher than that and possibly scaled the scale. I needed to put a title there, so that shows the rainfall in millimetres. I needed to put days of the week to show what the time period was, and that was the week beginning the 18th of January. And I need to put a title for my whole graph. Now I actually should have put rainfall in the Lithgow because that's where I measured it from. Step 3 is to plot your data from the table. So I will show you in another slide my data on the table. So I created a table to write down how much millimetres of rain there was each day. So on Monday there was 4 millimetres, on Tuesday there was 3.5, on Wednesday there was 3, on Thursday there was 2, and on Friday, Saturday and Sunday there were 0. So you put a little dot or a little X to plot your data. And then step 4, you carefully draw a line through all your plots. And that line shows how the rainfall has changed over time. So we can see that there was quite an average rainfall on a Monday, and then it got less and less as the week went on. So what is the difference between a bar graph and a line graph? Well, a line graph is purely used to show data over a period of time, and a bar graph is used to display most other types of data. So your task. If you feel that you are a bit unsure about line graphs, you can watch this video over again. But if you feel you would prefer to just keep practicing bar graphs, then choose the mild challenge, where you're going to read the bar graph on the sheet and answer the questions. You can also create your own questions about the bar graph. If you feel you think you quite understand line graphs, then let's see if you can read them. So here we have a line graph of sun temperatures over the summer holiday. It's just made up. Thought I'd give you some nice thoughts about the summer. You can answer these 6 questions to see if you can read that line graph. And if you really want to challenge yourself, why not create your own line graph to show your weather data? Now, I did put that task 2 weeks ago to record the temperature, the rain and the wind using your rain gauge and your wind sock. But if you haven't managed to do that, then you can always use my data, which I have displayed in a chart here. You could just choose temperature, you could choose rainfall, or you could choose wind. Or if you really want to challenge yourself, you could do all 3, but I'd advise just choose one. I have put online some graph paper. If you have a printer, you can print that off. If not, and you still want to do the graph, you can draw it on your own paper, or you can do it on class notebook. Thank you so much. If you have any questions, then please message me.